In the first video presenting the technology, we mentioned that the ESWave behaved, showing two applications in generation mode, and we have already analyzed its first application where the ESWave behaves as a point absorber. We also mentioned that the ESWave harnesses the power of the waves, collecting the waves' heave on the way up. Waves produce a force that always points upwards, which means that on the way down, the wave normally does not produce positive energy. In fact, it reduces the energy that can be harnessed. This is why, in its second application in generation mode, the ESWave gets locked slightly to synchronize its way down with an almost free-fall motion, avoiding as much as possible the negative interaction of the wave during the descent. It is also clear that the perfect harnessing process comes with a very light weight of the device on the way up and a very heavy weight of the device on the way down. This is why the ESWave changes its weight dynamically, resulting in a significant increase of yield. Let's see how this happens. The ESWave has a ballast tank surrounding the buoyant body. This tank is called the DCT, standing for Dynamic Compensation Tank. Its name obeys to the fact that the tank and hence the entire reciprocating assembly can be either in open or closed communication with the ocean. In open communication, the ocean remains within the dynamic compensation tank, but it does not ballast the device because the water belongs to the ocean and not to the reciprocating assembly. In other words, the ocean does not work to lift up the water within the DCT, and therefore this water does not ballast the ascent. Once the device reaches its highest point, the dynamic compensation tank closes, trapping the water in it. Now the reciprocating assembly is in closed communication with the ocean. Instantaneously, both the submerged volume and the overall weight of the reciprocating assembly increase. This increase in weight changes the dynamics between the ascent and the descent, since the increase in weight along with the downward stroke is also a source of energy. A preliminary hydrodynamic study conducted by the reputed consultancy TADEC envisaged an outstanding improving performance as a result of this approach. The figure shows an excerpt of that study providing desktop proof of concept and illustrates what is labeled as weight changing energy. In that figure, a 100 kilowatt wave produces 75 kilowatt blue curve when a traditional WEC, a wave energy converter, is used, and 190 kilowatt when our dynamic compensation tank, red curve, is implemented. This preliminary hydrodynamic study is now backed by 5 professionals in the marine renewable energy industry, having 4 of them the PhD level, which converts the study in a peer-reviewed desktop proof of concept. Moreover, one of the backers is a wave developer, and another works as technical authority for offshore wind at a reputed company. This dynamic change of mass is a process where the device traveling down lends energy from the ocean, releasing it back to the ocean when the device reaches its trough. Now you know that the ESWave is not just one more point absorber, but a dynamic machine, bringing the first use of a weight-changing mechanism to explore a new area of physics, where what goes up is different than what goes down.